astronomers laughed at the faint glow of 3I-ATLAS, until it reflected a light science couldn't Expla. In the deepest reaches of the cosmic tapestry, where the fabric of spacetime stretched thin and ancient light journeyed for eons, astronomers continually cast their digital nets, hoping to ensnare the faintest whispers of new celestial bodies. Most detections were mundane, predictable echoes of stellar nurseries, distant galaxies, or the silent drift of rogue planets, each new entry dutifully catalogued and filed away into the ever-expanding archives of human knowledge. But occasionally, a signal would emerge from the noise, a fleeting anomaly that, for a brief moment, would pique curiosity before usually conforming to known astrophysical models, settling comfortably within the established parameters of physics. Such was the initial, almost dismissive, encounter with 3I-ATLAS. Designated prosaically as 3I-ATLAS by the automated sky survey that first flagged its existence, it was nothing more than a faint, almost imperceptible smudge of light against the inky blackness. Its coordinates, when first cross-referenced against established catalogs, yielded no known object. It was, to all initial appearances, a transient, perhaps a distant, dying star, a minor debris field, or even a calibration error. The algorithms, designed to filter out such faint, unremarkable signals from the terabytes of daily data, almost succeeded in consigning 3I-ATLAS to the digital dustbin of unconfirmed and likely uninteresting astronomical phenomena. The ATLAS, Asteroid Terrestrial Impact Last Alert System, telescopes, a network of 4 0.5-meter robotic instruments spread across Hawaii and Chile, were primarily designed for wide-field surveys, scanning the entire observable night sky several times a night to detect rapidly moving objects. The 3I designation simply indicated it was the third instance of an interstellar object detected by this specific subset of the ATLAS system that defied immediate classification as a standard solar system body. Even the interstellar part was a placeholder, a default tag for anything that didn't fit neatly into the planetary or asteroidal bins, often just meaning too far away or moving too fast to be local debris. Dr. Eris Thorne, a veteran astrophysicist at the Mauna Kea observatories, remembered scrolling past its initial alert on a particularly tedious Tuesday morning. He had been sifting through preliminary data from the ATLAS system, primarily focused on refining algorithms for detecting near-Earth objects. His eyes, accustomed to the flickering streams of data, barely registered the low-priority flag. The raw spectral data, when eventually extracted and processed by a junior intern, offered little to excite. A surprisingly flat continuum, with barely discernible absorption lines, hinted at a composition of common elements like hydrogen and helium, but nothing definitive, nothing that screamed for immediate attention. It was faint, incredibly faint, requiring significant integration time even for the most sensitive instruments to yield a barely coherent signal. Just another faint glow, probably a distant, poorly resolved galaxy or a background quasar that our algorithms are struggling with, Thorne had mused, stifling a yawn during a team meeting held in the dimly lit control room, the rhythmic hum of cooling systems a constant backdrop. His colleague, Dr. Lena Petrova, a specialist in exoplanetary atmospheres known for her pragmatic approach, had chuckled. Or perhaps, she'd offered with a wry smile, pushing her glasses up her nose, it's just the universe's way of showing us another speck of dust. We see millions of these. What makes this one special, Eris? Thorne, a respected figure whose pronouncements often carried the weight of decades of observation, had simply shrugged. The general consensus among the early reviewers, a panel of senior astronomers who reviewed all new interstellar candidates, was that 3I-ATLAS was, at best, a curiosity for a rainy day, a low-priority target for future, more powerful telescopes, or more likely, a statistical anomaly destined to fade from memory, lost in the vast sea of cosmic detritus. The laughter, though gentle and good-natured, was nonetheless dismissive, a collective sigh of relief that this particular anomaly wasn't going to disrupt their carefully ordered universe. Yet, something about 3I-ATLAS continued to nag at a few, quieter corners of the astronomical community. Perhaps it was its peculiar trajectory, which, while not overtly anomalous, didn't perfectly align with any predicted paths for known celestial mechanics, hinting at a slight, almost imperceptible deviation from gravitational norms. Or perhaps it was the sheer stubbornness of its faint signal. It refused to completely vanish, persisting across multiple observation runs from different ATLAS sites, subtly shifting its position against the background stars with a deliberation that suggested a true, physical object, rather than a fleeting cosmic ray hit or instrumental ghost. Dr. Evelyn Reed, a young, ambitious postdoctoral researcher with a penchant for identifying outliers in vast datasets, found herself drawn to 3I-ATLAS during her off hours. She wasn't looking for anything revolutionary, merely trying to refine her own algorithms for detecting unusual light curves among faint, distant objects. 3I-ATLAS, with its almost stubbornly constant, yet incredibly faint, luminosity, presented an interesting challenge to her code. It was too constant, almost unnaturally so, for an object so distant and seemingly unremarkable. Most faint, distant objects exhibit some degree of variability, even if subtle, due to rotation, atmospheric effects, or interaction with surrounding dust and gas. 3I-ATLAS was a steady, unwavering pinpoint, a candle flame in a cosmic hurricane that refused to flicker. This unnatural stability, a whisper of defiance against the chaotic background of the cosmos, was what first caught Reed's meticulous eye. It was during one of Reed's deeper dives into the archived data, specifically cross-referencing observations from different instruments and filters, that the first true anomaly began to manifest. She was using a sophisticated deconvolution algorithm, a cutting-edge piece of software she had largely developed herself, to sharpen the faint image of 3I-ATLAS, attempting to resolve any subtle morphology. What she expected was a simple point source, or at most, a slightly elongated smudge. Instead, in a handful of the longest exposure images, taken with specific narrowband filters designed to isolate atomic emissions like hydrogen alpha, H-alpha, or oxygen 3, she began to detect something else. Not from 3I-ATLAS itself, but around it. Faint, almost ghost-like wisps of light, seemingly emanating from the object, yet not conforming to typical emission or scattering patterns. These wisps were not consistent across all filters. They appeared most prominently in filters designed to isolate specific atomic emissions, but their spectral signatures, when isolated, were utterly baffling. They didn't match the expected emission lines of any known element or compound. They were shifted, broadened, and sometimes, entirely new. It was as if 3I-ATLAS was not merely emitting light, but reflecting it, or perhaps, re-emitting it in a way that defied conventional physics. The light wasn't just faint, it was wrong. Reed initially dismissed her findings as instrumental noise, perhaps an artifact of her powerful deconvolution algorithm, a phantom born of overprocessing. She ran the data again, with different parameters, on different computing clusters, even using older, less aggressive methods. The wisps persisted, faint but undeniable, like a persistent echo. She then cross-referenced her findings with the raw, unprocessed frames from the ATLAS telescopes and even some follow-up observations from the much larger, 8.2-meter Subaru telescope on Mauna Kea, which had briefly observed 3I-ATLAS as part of a general sky survey. There, albeit even fainter and requiring immense digital magnification, they were spectral fingerprints that didn't belong. They were incredibly narrow, almost perfectly monochromatic, far sharper than any natural emission line, and they appeared to fluctuate in intensity with no discernible pattern, sometimes appearing and disappearing within minutes. She showed her preliminary results to her supervisor, Dr. Kenji Tanaka, a stoic but brilliant figure known for his meticulous verification processes and his unwavering commitment to scientific rigor. Tanaka, with decades of experience in optical astronomy and high-resolution spectroscopy, frowned at the data displayed on Reed's holographic projection. "Evelyn, this looks like contamination. Are you sure about your background subtraction? Have you checked for cosmic ray hits that weren't properly filtered? Or perhaps a data compression artifact?" Reed assured him she had. She had spent weeks meticulously rechecking every step, every parameter, every raw pixel. "The patterns are too consistent, Dr. Tanaka, too structured to be random noise. And the spectral lines, they simply don't make sense. They're too narrow, too precise, and they shift in ways that defy the Doppler effect or any known astrophysical process." Tanaka, intrigued despite himself, agreed to allocate some emergency observation time on a smaller, dedicated instrument at the observatory, the Gemini North Telescope's GMOS, Gemini Multi-Object Spectrograph, just to rule out Reed's findings. He still believed it was an error, a rookie's over-enthusiasm, but her persistence, and the sheer peculiarity of the data, warranted a second, more powerful look. The stakes, though unvoiced, were high. To claim a truly anomalous spectral signature was to invite intense scrutiny, and potentially, ridicule. The new observations, taken with the dedicated high-resolution spectrograph over several nights, were designed to be definitive. They were meant to either confirm Read's noise or, more likely in Tanaka's mind, prove it to be an artifact of her analysis. Instead, they did neither. They confirmed the presence of the anomalous spectral features, but amplified them, revealing an even more perplexing reality. The faint glow of 3I-ATLAS was indeed reflecting light, but not in any way known to astrophysics. When the light from 3I-ATLAS passed through GMOS and then later, through the even more precise high-resolution Echelle spectrometer, on the Keck telescope, it revealed not just the expected, albeit faint, continuum, but a series of incredibly sharp, narrow emission lines that defied classification. These lines were not broadened by thermal effects, nor redshifted/blue shifted by velocity in any predictable manner that would make sense for a distant object. Furthermore, they appeared to shift and change over relatively short timescales, sometimes appearing and disappearing within minutes, violating every principle of stable atomic emission or even the most exotic quantum fluctuations. It was as if the object was generating or manipulating light in ways that were fundamentally alien to their understanding of matter and energy. Tanaka, now visibly unnerved, called an emergency meeting with Thorne and Petrova, the very astronomers who had initially dismissed 3I-ATLAS. The holographic projections of the spectral data shimmered in the darkened conference room, each line a silent testament to the unraveling of conventional wisdom. "These are not standard emissions," Tanaka stated, his voice low and serious, gesturing towards a particularly jagged, unidentifiable peak that seemed to defy the very concept of spectral physics. "They don't correspond to hydrogen, helium, carbon, oxygen, or any element on the periodic table we know. Nor do they look like molecular bands. And they are far too narrow, far too specific, for a blackbody radiator or diffuse nebula. The coherence is unprecedented for a natural cosmic source." Petrova, who had once chuckled at the mention of 3I-ATLAS, now leaned forward, her brow furrowed in deep concentration, her earlier skepticism replaced by a profound unease. "It's as if it's producing light that doesn't originate from atomic transitions or thermal processes," she murmured, her voice barely a whisper, echoing the chilling thought that had begun to form in all their minds. Thorne, initially skeptical and still clinging to the hope of a mundane explanation, stared intently at the graphs. He zoomed in on a segment where a series of lines rapidly appeared and then vanished, only to reappear with slightly different intensities and slightly altered wavelengths moments later. "This isn't just an unknown element, Kenji. This is something else entirely. The temporal variability alone is impossible for stable matter. The sheer precision of these lines, their monochromatic purity, it's like nothing we've ever observed." The initial laughter had long since died. It was replaced by a chilling silence, punctuated only by the hum of the data projectors. The faint glow of 3I-ATLAS, once a cosmic joke, was now a profound, unsettling mystery, challenging the very foundations of their understanding of the universe. The term reflection itself began to feel inadequate, a feeble attempt to categorize the truly inexplicable. It wasn't merely bouncing ambient light, it was transforming it, or perhaps, generating light with characteristics that no known physical process could explain. The reflected lights were not simply shifted wavelengths of incident light, they were entirely new spectral signatures, appearing in precise, almost surgical patterns, like a finely tuned instrument. They were discrete, not continuous, suggesting a highly organized, rather than chaotic, process. When external light sources, such as nearby stars or even the diffuse galactic background, were carefully factored in, the anomalies persisted, proving they were intrinsic to 3I-ATLAS itself. The object seemed to be interacting with its environment in a way that bypassed the fundamental laws of spectroscopy, thermodynamics, and even quantum mechanics. It was as if the light was being processed through an unknown medium or mechanism, re-emerging with properties that were utterly alien. The emission lines were often incredibly sharp, almost laser-like, far narrower than anything produced by even the coldest, most quiescent nebulae. This suggested a coherence that was deeply unsettling. Coherent light, like that from a laser, is typically generated under very specific, controlled conditions. To see it emanating from a seemingly natural, distant celestial object was simply unheard of. They ran simulations, trying to model obscure quantum phenomena, exotic matter interactions, even speculative theories involving dark matter or extra dimensions. Nothing fit. Every model they tried to construct crumbled under the weight of the observed data. The light wasn't just unexplained, it was unexplainable within the current paradigm of physics. The energy required for such rapid, coherent emission and absorption, the spectral purity that defied thermal broadening, the lack of any corresponding absorption or emission lines for known elements, it all painted a picture of an object that simply should not exist, or at least, not function in the way it demonstrably did. Word began to spread, cautiously at first, through hushed conversations in observatory common rooms and encrypted email chains. The initial dismissal of 3I-ATLAS as a faint glow gave way to a growing, almost palpable sense of unease. Other observatories, alerted by Reid and Tanaka's carefully worded, peer-reviewed preprints, which still avoided definitive claims, instead focusing on unusual spectral anomalies of unknown origin, began to point their own instruments at the enigmatic object. From the European Southern Observatory's Very Large Telescope, VLT, in Chile to the powerful capabilities of the Hubble Space Telescope, independent teams replicated the findings. The results were universally consistent, the same baffling, non-standard spectral lines, the same impossible variability, the same coherent, laser-like emissions. The data was irrefutable. Yet, the implications were terrifying. If the universe contained objects that could manipulate light in such a way, what else were they missing? What fundamental laws had they misapprehended? The laughter was now a distant, embarrassing memory. It was replaced by a gnawing anxiety, a fear of the unknown that permeated the very foundations of their scientific certainty. The faint glow of 3I-ATLAS, once a cosmic joke, had become a cosmic riddle, a silent, distant challenge to everything they thought they knew, a beacon of impossible light in the vast, dark ocean of space. The initial, carefully structured paper, published in a leading astrophysical journal under the innocuous title, Anomalous Coherent Spectral Signatures Associated with Object 3I-ATLAS, sent not a shockwave, but a peculiar tremor through the global astronomical community. It was a tremor that registered first as skepticism, then as curiosity, and finally, as an unsettling dread. Dr. Evelyn Reid, now propelled from ambitious postdoc to a name whispered in academic corridors, found herself at the epicenter of this seismic shift. Her initial findings, meticulously verified and expanded upon by Dr. Tanaka and the Mauna Kea team, had irrevocably punctured the comfortable bubble of astrophysical certainty. The paper, a masterpiece of scientific reticence, presented only the raw data and the irrefutable evidence of spectral lines that defied all known physics. It avoided speculative interpretations, but the implications hung heavy in the academic air, unsaid yet omnipresent. Within weeks, the allocation committees for every major telescope on Earth and in orbit were inundated with proposals. Observatories from the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile to the Gran Telescopio Canarias, GTC, in the Canary Islands, and even the aging but still formidable Hubble Space Telescope, turned their collective gaze towards the faint, impossible glow of 3I-ATLAS. The data poured in, a torrent of confirmation that only deepened the mystery. Every independent observation, across a multitude of wavelengths and instruments, corroborated the Mauna Kea team's findings. The incredibly sharp, coherent emission lines, their inexplicable temporal variability, and their complete lack of correspondence to any known atomic or molecular transitions were undeniable. The initial dismissive laughter had indeed vanished, replaced by a cacophony of urgent, often bewildered, discussions. Dr. Eris Thorne, once the epitome of seasoned pragmatism, now found himself constantly reviewing the reams of data, his office walls plastered with spectral graphs. He saw patterns that defied logic, shifts that violated Doppler principles, and coherences that shouldn't exist outside of a laboratory. The comfortable universe he had spent decades observing was cracking at the seams. It's like looking at a perfectly tuned instrument playing a melody with notes that aren't on any scale we know, he muttered one sleepless night to Dr. Lena Petrova, who was equally engrossed in a holographic projection of 3I-ATLAS's light curve, which pulsed with an erratic, yet strangely precise, rhythm. And the instrument itself is invisible, or at least, undetectable by any means we possess, save for its impossible song. Petrova, usually grounded in empirical data, confessed to a growing sense of unease. The energy budget alone, Eris. To produce such narrow, high-energy emissions, and to have them appear and disappear within minutes, it demands an energy source, or a mechanism, that operates on scales far beyond anything we've conceived for natural celestial objects. Unless it's not natural. The unspoken word, artificial, hung like a pall in the room. The scientific community fractured into several camps. The largest, still clinging to the bedrock of known physics, proposed increasingly exotic, yet ultimately unsatisfying, natural explanations. Theories ranged from highly speculative states of matter existing under extreme pressures in a superdense core, to interactions with undiscovered dark matter particles, or even distortions of spacetime itself on a microscopic scale that somehow manifested as these spectral anomalies. Each theory, however elegant in its formulation, crumbled under the weight of empirical data. None could adequately explain the simultaneous coherence, variability, and the alien nature of the spectral lines. A smaller, more radical faction, often dismissed as fringe, began to openly discuss the possibility of an engineered origin. This was met with fierce resistance from the mainstream, particularly from senior astronomers who viewed such suggestions as an affront to scientific rigor, bordering on science fiction. Dr. Kenji Tanaka, while privately acknowledging the chilling implications, publicly maintained a stance of cautious scientific inquiry, emphasizing the need for more data and ruling out all natural explanations before even considering the A word. He shielded Reed from much of the public scrutiny, knowing her career was still nascent and could be easily damaged by association with such radical ideas. The pressure on the Mauna Kea team was immense. They were besieged by media requests, academic invitations, and an endless stream of speculative emails from both esteemed colleagues and enthusiastic amateurs. Reed, though exhilarated by the scientific breakthrough, found herself increasingly isolated, her passion for discovery tinged with a growing fear of the unknown. Every new observation just adds another layer of impossibility, she confided to Tanaka one evening, staring at another batch of baffling data from the VLT. This data showed not just the shifting spectral lines, but also faint, rhythmic fluctuations in 3I-ATLAS's overall luminosity, fluctuations that seemed too regular, too organized, for a random cosmic event. It's as if it's communicating, or at least, signaling a presence, in a language we don't understand. Tanaka, his face etched with fatigue, nodded slowly. The coherence is the most troubling aspect, Evelyn. Natural phenomena tend towards entropy, towards diffusion. This object displays an almost deliberate precision. It's like finding a perfect crystal in a cosmic mudslide, but a crystal that changes its lattice structure every few minutes without any thermodynamic justification. The demand for telescope time reached a fever pitch. A global consortium was quickly formed, pooling resources and observations, but even with the combined might of Earth's instruments, 3I-ATLAS remained a frustratingly elusive enigma. It was always faint, always distant, a cosmic needle in an infinite haystack, refusing to yield its secrets easily. Radio telescopes, scanning across the electromagnetic spectrum, detected no conventional radio emissions. X-ray and gamma-ray observatories found nothing beyond faint background noise. Gravitational wave detectors, initially hopeful given the object's anomalous trajectory, registered nothing out of the ordinary, suggesting its mass, while significant, wasn't undergoing any cataclysmic events. Then came the subtle, yet profound, shift in the object's behavior. Early trajectory analyses had noted a slight deviation from purely gravitational motion, but it was so minimal it had been attributed to measurement error or the influence of an unseen, mundane companion. However, with vastly improved astrometric data from multiple observatories, the deviation became undeniable. 3I-ATLAS was not following a simple Keplerian orbit around any known galactic center, nor was it merely a rogue object on an unperturbed interstellar trajectory. Its path showed minute, almost imperceptible, adjustments. These adjustments were not continuous or random, they were discrete, occurring in sudden, brief bursts that subtly altered its velocity vector. Each adjustment was too precise, too deliberate, to be a natural interaction with interstellar gas or a gravitational slingshot from an unseen body. It was as if the object possessed a form of propulsion, however subtle, that allowed it to course-correct in the vast emptiness of space. This new data, presented by Reed at a closed-door international conference, ignited a firestorm of debate. Propulsion? Are you suggesting it's a ship, Dr. Reed? Demanded a prominent astrophysicist from Caltech, his voice dripping with incredulity. That's an extraordinary claim, requiring extraordinary evidence, far beyond a few anomalous velocity vectors. Reed, though nervous, held her ground. "We are not claiming it is a ship, Professor. We are presenting data that indicates non-gravitational influences on its trajectory that cannot be explained by any known natural phenomenon. The shifts are too precise, too sudden, and lack any corresponding energy signature in other wavelengths that would suggest, for example, a cometary outgassing event." Dr. Thorne, now a staunch defender of Reed's meticulous work, stepped in. "The energy required for such precise, discrete changes in momentum, without any detectable exhaust plume or waste heat, challenges our understanding of propulsion, just as its light defies our understanding of spectroscopy. We are simply reporting what the universe is showing us, however unsettling." The conference ended in a stalemate, but the seed of a truly radical idea had been planted. The object wasn't just emitting strange light, it was moving in a way that defied simple physics. The pressure on the Mauna Kea team intensified, but this time, it was less about confirming anomalies and more about deciphering the intent behind them. What kind of object could manipulate spacetime or energy with such surgical precision? Petrova, usually so reserved, became obsessed with the temporal variability of the spectral lines. She developed complex algorithms to search for patterns, for rhythms, for anything that hinted at an underlying structure. Weeks blurred into months as she fed petabytes of data into supercomputers, mapping every flicker, every appearance, every disappearance of the impossible lines. And slowly, painstakingly, a faint pattern began to emerge. It wasn't a simple rhythm, nor a repeating sequence. Instead, it was more akin to a complex, nonlinear progression, a sequence of states that seemed to evolve over time, like an incredibly slow, intricate dance. "It's not random, Eris," she announced one morning, her eyes bloodshot but alight with a feverish intensity. "And it's not a simple code or a beacon. It's a process. The spectral shifts, the appearance and disappearance of specific lines, the subtle changes in their monochromatic purity, they seem to be responding to something. Or perhaps, performing something." Thorne leaned over her shoulder, examining the intricate, multidimensional graph that shimmered before them. "Responding to what, Lena? Its environment? Or us?" The question was chilling, a sudden leap from passive observation to active interaction. As if in answer, a new, unprecedented anomaly manifested. For several Earth days, 3I-ATLAS had maintained its usual faint, enigmatic glow, its spectral gymnastics continuing unabated. Then, without warning, the object's overall luminosity, while still faint, increased by a factor of 10. This wasn't a sudden flare, but a steady, deliberate brightening that lasted for precisely 36 hours before slowly dimming back to its baseline. During this brightening phase, the anomalous spectral lines did not simply become more intense, they shifted again, coalescing into a single, incredibly powerful, ultra-narrow emission that pulsed with a regularity that was utterly unlike anything observed before. This single line was so pure, so coherent, that it pushed the limits of every spectrograph, almost overloading the detectors. Its wavelength, when precisely measured, did not correspond to any known physical constant or atomic transition. It was a unique signature, a perfectly tuned frequency that seemed to scream its singularity across the vast cosmic distance. The entire Mauna Kea team, along with hundreds of other astronomers worldwide, dropped everything to study this event. It was as if 3I-ATLAS had decided, for a brief period, to reveal a fraction more of its true nature. The implications were staggering. If it could deliberately increase its output and focus its anomalous emissions into a single, perfectly coherent line, then its faint glow was not a limitation of its power, but perhaps, a choice. Dr. Reed, witnessing the real-time data streaming from the Keck telescope, felt a cold dread settle in her stomach. "It's not just reflecting light," she whispered, her voice barely audible. "It's controlling it. This isn't just a natural anomaly, Dr. Tanaka. This is a message. Or a demonstration." Tanaka, usually stoic, could only stare at the data, his knuckles white as he gripped the console. The precise duration of the brightening, the perfectly focused emission, the unique frequency, it was all too deliberate, too perfect to be random. The universe, which had always yielded to the patient probing of scientific inquiry, had just winked back, and its wink was utterly alien. The initial laughter had not only faded but had been utterly obliterated, replaced by a profound, almost existential, silence. The faint glow of 3I-ATLAS, once a source of academic amusement, was now a terrifyingly intelligent beacon, challenging the very notion of what was possible in the cosmos, leaving humanity to grapple with the unnerving reality that they might not be alone, and that whatever was out there, operated on principles utterly beyond their current comprehension. The story of 3I-ATLAS, far from being resolved, had only just begun its most unsettling chapter. The profound, almost existential, silence that followed the 36-hour demonstration of 3I-ATLAS's focused emission was not one of peace, but of a world holding its breath. The single, impossibly pure, ultra-narrow line of light that had briefly pulsed from the distant anomaly had seared itself into the collective consciousness of the astronomical community, a cosmic brand mark signifying the undeniable presence of something utterly alien. Dr. Tanaka, his face a mask of weary disbelief, ordered the data archived, replicated, and encrypted with unprecedented security protocols. He knew, with a certainty that chilled him to the core, that the faint glow of 3I-ATLAS had just transitioned from a scientific curiosity to a global imperative. The immediate aftermath was a maelstrom of frantic analysis, hushed conversations, and desperate attempts to find a terrestrial explanation. The unique frequency of the emitted line, precisely measured to the 10th decimal place, was scrutinized against every known physical constant, every mathematical sequence, every prime number series, and every theoretical particle decay spectrum. Nothing fit. It was a frequency unto itself, a perfectly tuned note in a symphony whose score was unknown, played by an instrument of impossible design. Dr. Petrova, driven by a profound need to find order in the burgeoning chaos, locked herself in her office for days, surrounded by holographic projections of the event. She scoured the data for harmonic relationships, for subtle modulations, for any echo of a comprehensible pattern. Her initial elation at confirming the object's deliberate control had curdled into a gnawing frustration. The signal was too clean, too singular, too devoid of the noise and complexity that characterize natural emissions. It was a statement, not a conversation. Dr. Eris Thorne, no longer stifling yawns but haunted by a persistent, low-grade anxiety, found himself poring over the historical data of 3I-ATLAS with a new, terrifying perspective. The initial dismissals, the good-natured laughter, now felt like a tragic prologue to an unfolding cosmic drama. He saw the subtle trajectory adjustments not as anomalies, but as deliberate maneuvers. The faint, unwavering pinpoint of light, once considered unremarkable, now seemed like a patient, silent observer. He felt a chilling sense of being watched, a profound reversal of the scientific premise where humanity was the sole, active observer of a passive universe. The universe, it seemed, was watching back, and it had chosen 3I-ATLAS as its inscrutable eye. Dr. Evelyn Reed, now an unwilling luminary, bore the brunt of the scientific community's bewildered inquiries. Her initial paper, once considered a bold but careful report on unusual spectral anomalies, was now the foundational text of an entirely new field of inquiry. She found herself drafting follow-up papers with Tanaka, each sentence weighed with the gravitational pull of its implications. The internal conflicts within the Mauna Kea team intensified, not due to personal animosity, but from the sheer, crushing weight of the unknown. They argued over semantics, over the phrasing of caveats, over the choice of adjectives, knowing that every word would be dissected, reinterpreted, and ultimately, used to either validate or condemn their findings. Tanaka, ever the stoic gatekeeper of scientific rigor, insisted on maintaining a scrupulously neutral tone in all public communications, even as his private conversations betrayed a deep, unsettling apprehension. He understood the precarious tightrope they walked: too much speculation, and they risked professional suicide; too much reticence, and they risked being dismissed as cowards in the face of an epical discovery. The global scientific community fractured under the pressure. The largest faction, still clinging to the bedrock of known physics, proposed increasingly exotic, yet ultimately unsatisfying, natural explanations. Theories ranged from highly speculative states of matter existing under extreme pressures in a superdense core, to interactions with undiscovered dark matter particles, or even distortions of spacetime itself on a microscopic scale that somehow manifested as these spectral anomalies. Each theory, however elegant in its formulation, crumbled under the weight of empirical data. None could adequately explain the simultaneous coherence, variability, the precise trajectory adjustments, and the alien nature of the spectral lines, let alone the deliberate, 36-hour burst. The energy budget alone for such a sustained, coherent emission defied any known natural process on that scale. A smaller, more radical faction, often dismissed as fringe just months prior, now found its voice growing louder, openly discussing the possibility of an engineered origin. This was met with fierce resistance from the mainstream, particularly from senior astronomers who viewed such suggestions as an affront to scientific rigor, bordering on science fiction. To leap from unexplained to alien intelligence is an intellectual surrender, thundered Professor Elias Vance, a Nobel laureate from Cambridge, during a heated virtual conference call. We must exhaust every conceivable natural explanation, no matter how improbable, before we succumb to such an extraordinary, and frankly, unscientific, conclusion. Yet, even Vance's voice carried a tremor of unease, a hint that even his formidable intellect was straining against the impossible. The pressure on the Mauna Kea team was immense. They were besieged by media requests, academic invitations, and an endless stream of speculative emails from both esteemed colleagues and enthusiastic amateurs. Reed, though exhilarated by the scientific breakthrough, found herself increasingly isolated, her passion for discovery tinged with a growing fear of the unknown. Every new observation just adds another layer of impossibility, she confided to Tanaka one evening, staring at another batch of baffling data from the VLT. This data showed not just the shifting spectral lines, but also faint, rhythmic fluctuations in 3I-ATLAS's overall luminosity, fluctuations that seemed too regular, too organized, for a random cosmic event. It's as if it's communicating, or at least, signaling a presence, in a language we don't understand. Tanaka, his face etched with fatigue, nodded slowly. The coherence is the most troubling aspect, Evelyn. Natural phenomena tend towards entropy, towards diffusion. This object displays an almost deliberate precision. It's like finding a perfect crystal in a cosmic mudslide, but a crystal that changes its lattice structure every few minutes without any thermodynamic justification. The demand for telescope time reached a fever pitch. A global consortium was quickly formed, pooling resources and observations, but even with the combined might of Earth's instruments, 3I-ATLAS remained a frustratingly elusive enigma. It was always faint, always distant, a cosmic needle in an infinite haystack, refusing to yield its secrets easily. Radio telescopes, scanning across the electromagnetic spectrum, detected no conventional radio emissions beyond the occasional, brief, highly directional bursts of the impossible light. X-ray and gamma-ray observatories found nothing beyond faint background noise. Gravitational wave detectors, initially hopeful given the object's anomalous trajectory, registered nothing out of the ordinary, suggesting its mass, while significant, wasn't undergoing any cataclysmic events that produced such distortions. The silence in other wavelengths was as deafening as the impossible song it sang in the visible spectrum. Then came the subtle, yet profound, shift in the object's behavior. Early trajectory analyses had noted a slight deviation from purely gravitational motion, but it was so minimal it had been attributed to measurement error or the influence of an unseen, mundane companion. However, with vastly improved astrometric data from multiple observatories, the deviation became undeniable. 3I-ATLAS was not following a simple Keplerian orbit around any known galactic center, nor was it merely a rogue object on an unperturbed interstellar trajectory. Its path showed minute, almost imperceptible, adjustments. These adjustments were not continuous or random, they were discrete, occurring in sudden, brief bursts that subtly altered its velocity vector. Each adjustment was too precise, too deliberate, to be a natural interaction with interstellar gas or a gravitational slingshot from an unseen body. It was as if the object possessed a form of propulsion, however subtle, that allowed it to course-correct in the vast emptiness of space, a celestial chess piece moving with calculated intent. This new data, presented by Reed at a closed-door international conference, ignited a firestorm of debate. Propulsion? Are you suggesting it's a ship, Dr. Reed? Demanded a prominent astrophysicist from Caltech, his voice dripping with incredulity. That's an extraordinary claim, requiring extraordinary evidence, far beyond a few anomalous velocity vectors. Reed, though nervous, held her ground. We are not claiming it is a ship, Professor. We are presenting data that indicates non-gravitational influences on its trajectory that cannot be explained by any known natural phenomenon. The shifts are too precise, too sudden, and lack any corresponding energy signature in other wavelengths that would suggest, for example, a cometary outgassing event. Dr. Thorne, now a staunch defender of Reid's meticulous work, stepped in. The energy required for such precise, discrete changes in momentum, without any detectable exhaust plume or waste heat, challenges our understanding of propulsion, just as its light defies our understanding of spectroscopy. We are simply reporting what the universe is showing us, however unsettling. The conference ended in a stalemate, but the seed of a truly radical idea had been planted. The object wasn't just emitting strange light, it was moving in a way that defied simple physics. The pressure on the Mauna Kea team intensified, but this time, it was less about confirming anomalies and more about deciphering the intent behind them. What kind of object could manipulate spacetime or energy with such surgical precision? Petrova, usually so reserved, became obsessed with the temporal variability of the spectral lines. She developed complex algorithms to search for patterns, for rhythms, for anything that hinted at an underlying structure. Weeks blurred into months as she fed petabytes of data into supercomputers, mapping every flicker, every appearance, every disappearance of the impossible lines. And slowly, painstakingly, a faint pattern began to emerge. It wasn't a simple rhythm, nor a repeating sequence. Instead, it was more akin to a complex, nonlinear progression, a sequence of states that seemed to evolve over time, like an incredibly slow, intricate dance. "It's not random, Eris," she announced one morning, her eyes bloodshot but alight with a feverish intensity. "And it's not a simple code or a beacon. It's a process. The spectral shifts, the appearance and disappearance of specific lines, the subtle changes in their monochromatic purity, they seem to be responding to something. Or perhaps, performing something." Thorne leaned over her shoulder, examining the intricate, multidimensional graph that shimmered before them. "Responding to what, Lena? Its environment? Or us?" The question was chilling, a sudden leap from passive observation to active interaction. As if in answer, a new, unprecedented anomaly manifested. For several Earth days, 3I-ATLAS had maintained its usual faint, enigmatic glow, its spectral gymnastics continuing unabated. Then, without warning, the object's overall luminosity, while still faint, increased by a factor of 10. This wasn't a sudden flare, but a steady, deliberate brightening that lasted for precisely 36 hours before slowly dimming back to its baseline. During this brightening phase, the anomalous spectral lines did not simply become more intense, they shifted again, coalescing into a single, incredibly powerful, ultra-narrow emission that pulsed with a regularity that was utterly unlike anything observed before. This single line was so pure, so coherent, that it pushed the limits of every spectrograph, almost overloading the detectors. Its wavelength, when precisely measured, did not correspond to any known physical constant or atomic transition. It was a unique signature, a perfectly tuned frequency that seemed to scream its singularity across the vast cosmic distance. The entire Mauna Kea team, along with hundreds of other astronomers worldwide, dropped everything to study this event. It was as if 3I-ATLAS had decided, for a brief period, to reveal a fraction more of its true nature. The implications were staggering. If it could deliberately increase its output and focus its anomalous emissions into a single, perfectly coherent line, then its faint glow was not a limitation of its power, but perhaps, a choice. Dr. Reid, witnessing the real-time data streaming from the 3I telescope, felt a cold dread settle in her stomach. "It's not just reflecting light," she whispered, her voice barely audible. "It's controlling it. This isn't just a natural anomaly, Dr. Tanaka. This is a message. Or a demonstration." Tanaka, usually stoic, could only stare at the data, his knuckles white as he gripped the console. The precise duration of the brightening, the perfectly focused emission, the unique frequency, it was all too deliberate, too perfect to be random. The universe, which had always yielded to the patient probing of scientific inquiry, had just winked back, and its wink was utterly alien. The initial laughter had not only faded but had been utterly obliterated, replaced by a profound, almost existential, silence. The faint glow of 3I-ATLAS, once a source of academic amusement, was now a terrifyingly intelligent beacon, challenging the very notion of what was possible in the cosmos, leaving humanity to grapple with the unnerving reality that they might not be alone, and that whatever was out there, operated on principles utterly beyond their current comprehension. The story of 3I-ATLAS, far from being resolved, had only just begun its most unsettling chapter. The global media, initially kept at bay by a carefully orchestrated campaign of scientific jargon and downplayed significance, could no longer be contained. A junior analyst at the European Southern Observatory, overwhelmed by the sheer volume of inexplicable data, made the fateful decision to leak a raw spectral graph and an internal memo discussing non-gravitational trajectory alterations to an independent science blogger. Within hours, the internet exploded. The phrase alien megastructure trended worldwide. Governments, previously content to observe from a distance, were now forced into reactive mode. The Mauna Kea team, once sequestered in their quiet mountain observatory, found themselves at the epicenter of a global storm. Their names, once known only in academic circles, were splashed across every tabloid and broadcast channel. Dr. Reed, in particular, became the face of the discovery, an unwitting protagonist in a narrative far grander and more terrifying than she could have imagined. Her private fears, her intellectual struggles, were now public fodder, dissected and sensationalized for mass consumption. The White House, along with a newly formed international coalition of scientific and defense agencies, convened an emergency summit. The question was no longer if 3I-ATLAS was an artifact, but what kind of artifact it was, and what its intentions might be. The consensus, however uneasy, was that active communication attempts were now paramount. Using the precise, solitary frequency emitted during the 36-hour event, a deep space radio array in the Atacama Desert, along with a powerful laser system in New Mexico, began to transmit a series of mathematical prime numbers, followed by a representation of the hydrogen atom, humanity's universal calling card. Days turned into weeks. The immense distances involved meant that any response would take years, if not decades, to arrive. The waiting became a new form of torture, a global vigil held under the indifferent gaze of an impossible star. But 3I-ATLAS did not wait years. Precisely 72 hours after the first human transmission, the object, which had returned to its baseline faint glow, abruptly shifted its behavior once more. This time, it wasn't a change in luminosity or spectral lines. Instead, a new, unprecedented phenomenon was detected by the ALMA array, a network of radio telescopes designed for exquisite sensitivity in millimeter and submillimeter wavelengths. A faint, incredibly broad, yet highly structured radio emission began to emanate from 3I-ATLAS. It was not a single frequency, but a complex, multi-band signal, unlike any natural astrophysical source. And within this noise, Petrova, still poring over every new data stream, detected a pattern. A repeating sequence of pulses, a rhythm that seemed to shift, subtly, with each repetition. It was complex, far beyond any human-generated code she knew, but it possessed an undeniable, internal logic. "It's not just a signal, Eris," she gasped, her voice raw with exhaustion and a terrifying exhilaration, pointing at a holographic projection of the radio spectrum. It's responding. The complexity, the sheer informational density, it's almost as if it's acknowledging our prime numbers, but then presenting us with an entirely new mathematical language, one that dwarfs our own in its intricacy. Thorne stared, his mind reeling. The radio emission was not a simple echo, nor a direct reply in the language humanity had sent. It was a leap, an expansion, a demonstration of a vastly superior understanding. The broad spectrum of the radio signal, combined with the impossible coherence of the light emissions, painted a picture of an object capable of manipulating energy across a colossal range of the electromagnetic spectrum with terrifying precision. Simultaneously, the astrometric data from the Hubble Space Telescope registered another, even more significant, change in 3I-ATLAS's trajectory. The subtle, discrete course corrections that had baffled them for months now coalesced into a discernible vector. The object was not merely drifting, it was accelerating. Slowly, imperceptibly at first, then with an increasing, deliberate pace, 3I-ATLAS was altering its course. And its new trajectory, when extrapolated, pointed not randomly into the void, but with unnerving accuracy, directly towards the inner solar system. The data, when presented to the international consortium, plunged the world into an even deeper crisis. The possibility of a distant, enigmatic alien intelligence was one thing. The reality of that intelligence now moving towards them, having seemingly acknowledged their attempts at communication with an incomprehensibly complex response, was another entirely. The debates over natural versus artificial origins evaporated, replaced by a singular, terrifying question: what happens when 3I-ATLAS arrives? The faint glow, once laughed at, then dismissed, then feared, was now a harbinger, a terrifyingly intelligent beacon on an undeniable course towards humanity's doorstep. The silence that followed this realization was not existential, it was primal. The primal silence, profound and unnerving, shattered with the dawn. News of 3I-ATLAS's acceleration towards the inner solar system, coupled with the incomprehensibly complex radio response, ripped through the carefully constructed veil of scientific reticence. The initial leaks had merely been tremors, this was a full-blown seismic event. Governments, once cautiously observing, now reacted with a desperate urgency. Within hours, a hastily convened emergency session of the United Nations Security Council, augmented by the world's leading scientific minds, declared a global state of unprecedented alert. The Mauna Kea team, once revered academics, now found themselves under the direct, unblinking gaze of countless intelligence agencies and military strategists, their every finding scrutinized for tactical implications. The idyllic isolation of the observatory was gone, replaced by the constant, low hum of advanced surveillance equipment and the unsettling presence of armed guards. Dr. Kenji Tanaka, his stoicism barely masking a deep-seated terror, found his observatory transformed into a de facto command center. Uniformed personnel, their faces grim, moved through the corridors, their presence a stark reminder that the academic pursuit of knowledge had now intersected with the raw calculus of planetary defense. He wrestled with the implications of the data, the sheer audacity of 3I-ATLAS's actions. It had not just responded, it had escalated. It had not just communicated, it had launched a challenge, an intellectual gauntlet thrown across the vastness of space, followed by an undeniable, physical trajectory. The weight of being the primary conduit for such world-altering information pressed down on him, threatening to fracture his legendary composure. He found himself questioning not just the nature of 3I-ATLAS, but the very capacity of humanity to confront such an absolute unknown. Dr. Lena Petrova, fueled by caffeine and an almost manic determination, plunged herself into the labyrinthine depths of the radio signal. The initial response had been merely a hint. Now, with continuous, higher-resolution data streaming from ALMA and other global arrays, the true complexity of 3I-ATLAS's mathematical language began to unfold. It wasn't just a pattern, it was a layered structure, a fractal symphony of information that seemed to defy conventional data compression. She identified repeating motifs, but they were never identical, always subtly transforming, evolving, as if perpetually interacting with some unseen variable. It was like trying to understand a novel by analyzing its grammar, only to find the grammar itself was shifting with every sentence, each iteration adding new layers of meaning that humanity's most powerful supercomputers struggled to process. "It's not a static message, Eris," she explained to Thorne one night, her voice hoarse, pointing at a shimmering projection that pulsed with alien logic. "It's a living algorithm. It's too dynamic, too adaptive. It's like watching a mind think, but a mind whose thoughts are expressed in pure mathematics, unbound by human concepts of number or form. We're not just trying to translate, we're trying to comprehend a new form of consciousness, expressed in a medium we barely grasp." Thorne, his face drawn, could only stare, the vastness of the intellectual chasm between humanity and 3I-ATLAS growing ever wider, filled with the terrifying echo of an alien intellect. The trajectory data, meanwhile, became the focus of intense, global scrutiny. Dr. Evelyn Reed, her youthful ambition now overshadowed by a profound sense of responsibility and an almost paralyzing fear, led the international astrometric efforts. Every pixel from Hubble, every data point from the VLT, was fed into supercomputers, attempting to predict 3I-ATLAS's exact path, its closest approach, its potential impact zone. The acceleration, while still subtle by astronomical standards, was relentless. It wasn't a runaway object, it was a guided missile, albeit one moving at velocities that made human-made projectiles seem like crawling insects. The projected arrival time, initially estimated in decades, began to shrink, first to years, then to a terrifyingly finite number of months, then weeks. Panic, once a whisper, became a roar that echoed across continents, amplified by a global media desperate for answers and hungry for sensation. Reed, once a quiet observer of distant stars, now found herself the reluctant spokesperson for humanity's greatest crisis, her name inextricably linked to the approaching enigma. She wrestled with the ethical implications of her findings, the knowledge that her discovery, once a source of academic pride, had become the catalyst for global dread. The global scientific community, once divided by theoretical camps, now found itself unified by a common, terrifying goal: to understand, or at least predict, the intentions of 3I-ATLAS. The unnatural phenomenon debate was dead, replaced by the stark reality of an artificial, intelligent entity on an intercept course. Arguments now revolved around interpretation: was it a probe, a scout, a terraforming device, a weapon, or something far more sinister and incomprehensible? A new branch of exosemiotics sprang into existence overnight, dedicated solely to deciphering 3I-ATLAS's radio and light emissions. Teams of linguists, mathematicians, cryptographers, and even philosophers were drafted into the effort, their diverse backgrounds representing humanity's desperate attempt to find a common ground with the alien, to grasp at any thread of familiarity in the face of absolute otherness. The sheer volume of data, the petabytes of spectral graphs, radio bursts, and trajectory plots, threatened to overwhelm even the most advanced processing systems, creating a new form of informational paralysis. The political landscape became a volatile arena. Nations, accustomed to vying for power, found themselves forced into an uneasy alliance, their historical animosities temporarily eclipsed by the looming existential threat. The Global Response Initiative (GRIC) was established, an unprecedented multinational effort to coordinate scientific research, defense strategies, and ultimately, a unified message of welcome or defiance. But beneath the veneer of unity, fear festered. Whispers of preemptive strikes, of desperate measures, began to circulate in the highest echelons of power. Some argued that waiting for 3I-ATLAS to arrive was an act of planetary suicide. Others countered that any aggressive act could provoke a catastrophic response from an entity whose power was clearly beyond human comprehension, perhaps even triggering an unwanted interstellar war. The debate raged, fueled by a mixture of scientific uncertainty, military doctrine, and raw human fear. Dr. Eris Thorne, haunted by the specter of his initial dismissals, became a vocal advocate for cautious observation and non-aggression. "We know nothing of its capabilities, save that they defy our physics and our imagination," he argued vehemently at a GRI strategy meeting, his voice tight with a newfound urgency. To assume hostility, or even to provoke it, would be folly of cosmic proportions. We are dealing with an intelligence that processes information and manipulates energy in ways we can barely conceive. Our weapons, our defenses, our entire framework of conflict, are likely irrelevant if it truly wishes us harm. Our only hope lies in understanding, not in confrontation. His words, though steeped in logic, often fell on deaf ears, drowned out by the rising tide of fear and the desperate need for actionable solutions, however ill-conceived. He felt a deep, gnawing frustration at humanity's instinct to militarize the unknown, rather than to humbly seek comprehension. The psychological toll on the Mauna Kea team was immense. Sleep became a luxury, their dreams plagued by shimmering spectral lines and alien algorithms. Dr. Reed, once energized by discovery, now felt a crushing weight of existential dread. She saw the fear in the eyes of her colleagues, the desperate hope in the public's gaze, and knew that the burden of interpretation lay heavily on their shoulders. She often found herself staring at the inky blackness of the night sky, a profound sense of loneliness washing over her. "It's like we've opened a door," she confided to Tanaka, her voice barely a whisper, "and now we have no idea what's on the other side, or how to close it. And worse, it seems to be stepping through, deliberately." The world outside the observatory was gripped by a growing panic. Conspiracy theories proliferated, cults emerged, and social order strained under the unprecedented pressure of an impending encounter with the utterly alien. Tanaka, though outwardly composed, felt the cracks forming in his own resolve. The precise, almost surgical, nature of 3I-ATLAS's maneuvers and emissions suggested not just intelligence, but a profound, almost artistic, control over fundamental forces. It was like watching a master sculptor at work, except the medium was space-time and light, and the sculpture was a trajectory towards Earth. He worried about the long-term implications, not just for humanity's survival, but for its very psyche. What would it mean to share the universe with such an entity? Would humanity's scientific achievements be rendered trivial, its philosophical foundations shattered? He felt a desperate urgency to find some anchor, some shred of comprehensible data, before the entire edifice of human knowledge crumbled. As 3I-ATLAS continued its inexorable approach, a new, subtle anomaly was detected, this time by the most powerful optical telescopes. The faint glow, now magnified by its relative proximity, began to show a peculiar phenomenon. Not a change in its overall luminosity, but a subtle, almost imperceptible distortion in the light from background stars as they passed behind it. It wasn't gravitational lensing in the conventional sense, the distortion was too sharp, too localized, and too transient, appearing as if 3I-ATLAS was not merely massive, but was actively bending or manipulating the fabric of spacetime around itself on a microscale. It was a phenomenon that defied general relativity, hinting at a technology capable of warping reality itself, not through immense mass, but through an unknown, precise application of energy. The implications were chilling. The object was not merely traversing space, it was sculpting it. Petrova, observing this new data, felt a new wave of terror, cold and visceral. "It's not just moving towards us, Eris," she whispered, her voice barely audible, her eyes wide with a mixture of horror and awe. "It's clearing its path. Or perhaps, preparing its environment. The spacetime distortions are too precise, too ephemeral to be natural. It's like it's carving a tunnel through the vacuum, making its approach even smoother, even more deliberate. Its very presence rewriting the cosmic laws around it." Petrova's voice trailed off, a profound sense of awe and terror battling for supremacy in her expression. Thorne, leaning over her shoulder, could only nod, his mind struggling to reconcile this new information with everything he had ever known. The initial laughter, the dismissive shrugs, now felt like echoes from a naive, long-lost past. The universe, which had once seemed vast yet comprehensible, was now revealing itself to be an intricate tapestry woven with threads of impossible physics and unimaginable intent. The revelation of active spacetime manipulation sent shockwaves far beyond the scientific community. The Global Response Initiative, a fragile alliance already strained by conflicting ideologies and mounting panic, teetered on the brink of collapse. The military factions, emboldened by the perceived threat, pushed harder for aggressive countermeasures, however futile they might seem. Generals and strategists, accustomed to the tangible realities of terrestrial warfare, struggled to grasp the implications of an entity that could carve a tunnel through the vacuum. Their models of defense were obsolete, their weapons likely impotent against a force that commanded the very fabric of existence. Thorne's plea for caution, for understanding over confrontation, became a desperate refrain against a rising tide of fear-driven militarism. He watched, horrified, as humanity's instinct for self-preservation threatened to manifest as self-destruction, a tragic echo of every historical conflict, now writ large on a cosmic scale. Dr. Reed, now working almost entirely from a secure, underground facility beneath Mauna Kea, found her days consumed by frantic data analysis and her nights plagued by nightmares of impossible light. The object's trajectory had become terrifyingly precise, its course corrections now discernible even to the naked eye through long-exposure telescopic images, appearing as faint, almost ethereal blips. The projected arrival time continued to shrink, a countdown to an unknown destiny. The world outside the bunker was in a state of barely contained chaos. Cities emptied, governments issued conflicting directives, and the internet, once a source of information, became a maelstrom of conspiracy theories, religious fervor, and raw, unadulterated terror. She saw the fear in the eyes of the armed guards, the desperation in the hushed tones of the generals, and the profound, almost spiritual, dread in the faces of her scientific colleagues. Her discovery, once a beacon of intellectual triumph, had become a harbinger of potential doom, a burden almost too heavy to bear. Petrova's work on the radio signal, meanwhile, yielded a terrifying new insight. The living algorithm was not merely complex, it was adaptive. It seemed to be responding not just to the initial prime number sequence, but to the subsequent human attempts to decipher it, subtly shifting its patterns, adding new layers of complexity, almost as if it were testing their intellectual limits, or perhaps, deliberately obscuring its true meaning as their efforts intensified. She discovered that certain mathematical progressions they tried to feed back into the signal would cause the alien emissions to subtly change, sometimes becoming even more intricate, sometimes simplifying in a way that felt like a deliberate, almost playful, challenge. "It's not just a message, Eris," she explained, her voice barely a whisper, her eyes wide with a mixture of terror and exhilaration. "It's a dynamic interface. It's interacting with us, intellectually. It's like a cosmic Turing test, but we're the ones being tested, and we're failing to grasp the very language of the examination." The implication was profound. Humanity was not merely observing an artifact, it was engaging with an active, vastly superior intelligence, one that was perhaps evaluating their very capacity for comprehension. As 3I-ATLAS drew closer, now visible as a distinct, albeit still faint, point of light to the most powerful backyard telescopes, the spacetime distortions intensified. They were no longer subtle blips, they were minute, yet measurable, ripples in the gravitational field, detected by Earth-orbiting observatories and even ground-based sensors. These ripples were not random, they were perfectly symmetrical, appearing as if the object was creating a localized, perfectly spherical pocket of altered spacetime around itself, a bubble of manipulated reality that allowed it to glide through the void with an efficiency that defied all known physics. It was not merely accelerating, it was transcending the limitations of velocity, subtly bending the very rules of the universe to its will. Then came the visual. The first truly resolved images, captured by the Hubble Space Telescope and then later by the new generation of adaptive optics telescopes, were both breathtaking and utterly incomprehensible. 3I-ATLAS was not a ship, not a planet, not even a traditional megastructure. It was a perfectly black, impossibly smooth spheroid, absorbing almost all incident light, a cosmic void against the backdrop of stars. Yet, around this absolute darkness, pulsed the impossible light that had first caught Reed's eye. Not from the object, but around it. The coherent spectral emissions, the laser-like lines that defied explanation, now manifested as a shimmering, multi-hued aura that constantly shifted, pulsed, and reformed, like a living, breathing nebula of pure, controlled light. It was a halo of impossible physics, a silent symphony of manipulated photons. The light was not reflected, it was generated or reconstituted from the ambient energy of space itself, processed and re-emitted in patterns and frequencies that hinted at a purpose far beyond mere illumination. The black spheroid was merely the locus, the engine, for this ethereal display. Dr. Tanaka, standing before the holographic projection of 3I-ATLAS, now so close it filled the entire display, felt a cold sweat prickle his skin. "It is not reflecting light, Evelyn," he stated, his voice devoid of its usual scientific detachment, now tinged with an almost spiritual dread. "It is resculpting it. It is taking the raw energy of the cosmos and reforming it into these impossible wavelengths, these coherent emissions. The dark sphere, it's not merely absorbing light. It's a nexus, a focal point for the manipulation of energy and spacetime itself." He gestured towards the shimmering aura. "This is its language. This is its propulsion. This is its being." The revelation was staggering. 3I-ATLAS was not merely a technological artifact, it was a manifestation of an intelligence that operated at a fundamental level of reality, manipulating the very building blocks of the universe. Its reflected lights were not passive, they were active, deliberate expressions of its will, its understanding, and perhaps, its purpose. The radio signal, Petrova now realized, was not just a mathematical challenge, it was a mirror, reflecting humanity's own attempts at comprehension, subtly modifying itself to reveal the limitations of their intellectual framework. It was showing them, through its own impossible existence, the vast chasm between their understanding of physics and its own mastery. As 3I-ATLAS continued its inexorable approach, now just weeks away from its closest predicted point within the solar system, a new, chilling pattern emerged from the flickering aura. The coherent light emissions began to form distinct, observable structures within the shimmering halo. Not symbols, not pictograms, but complex, three-dimensional geometric patterns that shifted and reconfigured with breathtaking speed and precision. These patterns were not random, they were impossibly intricate, self-similar, and seemed to encode information at a density that defied human comprehension. Petrova, working frantically, realized they were not merely geometric forms, but dynamic mathematical constructs, evolving in real time. "It's not trying to communicate in a human language, Eris," she gasped, pointing at a particularly complex, spiraling formation within the light. "It's communicating in the language of universal constants, of pure geometry, of fundamental physics." It's showing us the structure of reality, but through a lens we can barely perceive. It's like trying to read a textbook written in the very fabric of spacetime itself. Thorne, watching the impossible geometries unfold, felt a profound humility wash over him, eclipsing all previous fear. The initial laughter, the dismissive skepticism, now seemed like the arrogant folly of children marveling at a single drop of water, unaware of the ocean from which it came. This was not an invasion, it was an encounter with the sublime, a confrontation with a level of existence so far beyond human understanding that even the concept of hostility seemed trivial. The closest approach of 3I-ATLAS was not an impact, nor a catastrophic event. It simply passed. It swept through the outer solar system, its perfectly black core absorbing all light, its shimmering, impossible aura pulsing with silent, geometrically perfect emissions. It did not slow down, did not deviate, did not attempt any further conventional communication. Its trajectory, meticulously tracked by every instrument on Earth and in orbit, remained utterly consistent, a ballet of manipulated spacetime. It was as if its approach, its demonstration, its entire existence, was merely a fleeting, profound statement, an intellectual and existential challenge delivered across the light years. As it departed, receding back into the cosmic void, the spacetime distortions gradually faded, the impossible light emissions slowly dimmed, coalescing back into the faint, enigmatic glow that had first caught Reed's eye. The radio signal, too, became fainter, its complex patterns slowly dissolving into a pervasive, almost melancholic hum, a final, lingering echo of a conversation humanity had barely begun to understand. The world was left in a state of stunned, profound silence. The global panic, the military alerts, the desperate attempts at communication, all had been rendered irrelevant by the sheer, unyielding otherness of 3I-ATLAS. It had come, it had shown, and it had left, a cosmic enigma that had shattered humanity's comfortable illusion of cosmic solitude and intellectual supremacy. Dr. Evelyn Reed, now a figure of historical significance, spent the rest of her life dedicated to deciphering the remnants of 3I-ATLAS's message, pioneering an entirely new field of meta-astrophysics. She never fully understood it, but she found solace in the pursuit, in the endless, intricate beauty of the alien geometries it had briefly etched into the void. Her initial ambition had been replaced by a quiet, determined awe, a lifelong commitment to understanding the impossible. Dr. Lena Petrova, haunted by the living algorithm, continued to chase the faint echoes of its radio signal, convinced that within its fading patterns lay the key to a universal language, a new mathematics that transcended human perception. She published groundbreaking work on nonlinear information theory, forever altering humanity's understanding of communication and consciousness, but always with the quiet knowledge that the full scope of 3I-ATLAS's intellect remained tantalizingly beyond her grasp. Dr. Eris Thorne, now an elder statesman of astronomy, retired from active research, but became a powerful voice for humility and open-mindedness in science. He often spoke of the laughter of children in the face of the infinite, a poignant reminder of humanity's initial dismissiveness. His personal journey, from skepticism to profound reverence, became a parable for a scientific community forced to confront the limits of its own knowledge. He found a strange peace in the vastness of the unknown, accepting that some mysteries were not meant to be solved, but to be contemplated, to expand the very boundaries of human thought. Dr. Kenji Tanaka, the Stoic leader, guided the Mauna Kea team through the chaotic aftermath, maintaining scientific rigor even as the foundations of physics trembled. He oversaw the establishment of the 3I-ATLAS Institute, a global collaborative effort dedicated to understanding the object's legacy. He never lost his composure, but the deep lines etched on his face spoke of the immense burden he had carried, the silent dread of confronting an intelligence that made humanity's greatest achievements seem like mere whispers in the cosmic wind. The faint glow of 3I-ATLAS, now receding into the deepest reaches of space, no longer evoked laughter or fear. It was a permanent fixture in the human psyche, a silent, distant monument to a profound encounter. It had not brought war, nor salvation, but something far more unsettling, a mirror, reflecting humanity's own limitations, its intellectual hubris, and its place in a universe far stranger, far more complex, and infinitely more intelligent than it had ever dared to imagine. The story of 3I-ATLAS was not over. It had simply moved beyond the sphere of human comprehension, leaving behind a legacy of shattered paradigms and an enduring, terrifying question: what other impossible wonders lay hidden in the vast, silent tapestry of the cosmos, waiting for humanity to laugh, and then to truly see?